that like variables in JavaScript can be functions, as we have just earlier seen with callbacks, and that you can handle them in either way. Okay. Let's see. Oh, and here we have this, like, what we want to do next is we want to essentially like read data from a Dropbox and then dynamically change the content based on it. So here we have like a Dropbox that has pear, apple, and plum, and whenever we change that, we can see that the text here also updates. Again, a very simple operation. Okay, how do we do that? We create a new select, a drop-down select, with the ID drop-down, and give it these options. And so here, like we have option, we define its value, which is pear in this case, and here we define its label, its appearance. And so if you look here, this is like, here pear is capitalized, down here it's not capitalized. So if I, for example, I could, of course, like this is completely arbitrary what I put in here. Doesn't have to be pear. The second option here is the one that is selected by default, the apple selection, so otherwise it's just the same. And then we have, the third one is the plum. And then we have this div, which contains another span. The span is just like another HTML container, which in contrast to the div doesn't break the line. Yeah?
Do you have to set a default?
You don't, and if you don't, it's going to be the first one, I'm pretty sure. Yep. But if you want a default, you can set it. So here I have this span, which is just like an HTML container, and I give this an ID. This is where my fruit goes. So this is essentially an empty span, but I have like identified it by this fruit identifier with the purpose of later changing what it contains. And then what we do here is we initialize the fruit with the value of the Dropbox. So like the default value in this case. We simply do document get element by ID, drop down and access its currently set value, and assign that to the inner HTML of the fruit. And then here we add this onChange listener. Like whenever I've changed the Dropbox, this function is going to be called. And notice that this is an anonymous declaration function. The function doesn't have a name. And this function also gets an event passed in, and we can then use this event to retrieve the target of the event. So it was in this case the Dropbox, drop-down box, and then retrieve its value. And so this is how we can assign, like this is how we retrieve the current value of the drop-down box, and this is how we assign it to this span with the ID fruit, like document get element ID fruit. And so then we get this super nice interactive fruit chooser.
I had a question about that.
Sure.
Just about the difference between setting inner HTML versus appending text now.
The nice thing is with inner HTML you can actually write HTML, and with a text node, this is just an assignment to the variable, and the other one is a function call. I don't really know. There's like two different ways of doing it. You can assign HTML directly here. You can also retrieve the inner HTML directly through that. Two different ways. Basically, I'm not aware of any major differences. And there's like quite often there's these many different ways, and I'm trying to pick some of them. There's not always like obviously a great way to do them, or a better way to do them. Any other questions? Okay. And so there's of course, we've seen on click, on change, there's also on load, which is triggered whenever the page is loaded, on mouse over, on mouse out, whenever the mouse leaves an element, on resize, if I resize a window, and so on. So all of these events are pretty useful, and there's a large list of possible events. So on dragged exit, and so on. So like take a look at those whenever you need them. basically you can listen to like very, very many events in your browser. And then what we can also do is, like as I said before, we can do this to arbitrary HTML elements. So we can listen to arbitrary HTML elements. And so I have in this case created an SVG. And whenever I click it, it changes the color and increases the size. And so how did we do that? Like we started out with an SVG that we've defined. We styled it here, and it has like, it starts at position X, Y, 10. It has a width of 20 and a height of 20. So that was the initial configuration with an initial style of steel blue. Then I created a color array, and these are kind of like nice named colors in HTML, dark orchid, teal, and so on. The color count is essentially an index where I am with the colors. And then here I retrieve the element my bar, which we have assigned an ID here. And on click we execute this function. So we define that the rectangle is like we retrieve the target of the event, which is the rectangle. So this is now really the rectangle SVG DOM element. Then we retrieve the current width by simply parsing the attribute width out of this rectangle. And then we set the width here by increasing it by 10. So here current width plus 10, setting it, and then we simply set the style, the fill style here to a color out of our color array by this color count, which we continuously increase modulo 4. So because there's exactly 4 values in our in the color array, so we can nicely iterate over those. So this is then the result. We can simply dynamically change the appearance of that element. Okay, any questions about this? This is essentially everything that you need to know to build interactive web visualizations. Like everything from here on out is just to make it more efficient and to make it nicer and to make it better. But like just using the standard document object model API, you can build any web visualization. And actually, what D3 and jQuery and so on do under the hood is they essentially abstract these functions and make them more accessible. Okay, so like just as a side note, up to now you simply could just open up a file and open it up in your browser and run it there. That was like perfectly fine. That is safe, and also most of the examples of today would work like this. But whenever you start to load data, not from within the HTML, but whenever you start to work with files, then you have to run a web server. Because for security reasons, your web server isn't allowed to read local files. At least the default configuration of Chrome isn't. You can make Chrome actually read local files, and you can also make other browsers have different specifications, but your life is going to be easier if you run a web server. And so there's two different ways of running a web server. Like if you have Python installed, the simplest and cheapest one is just to run this Python -m simple HTTP server, and then, like for example, so Python -m HTTP.server. Now I'm running a new server on port 0 or at the address 0 and port 8000. And so here I'm running the course website locally on my computer. And so that's the simplest way, and that's the quickest way if you just want to like quickly look at somebody's code and need to run a web server. That's a good way to go. And so there's two different commands for that. That is, the one is in Python 2, this is the command, and in Python 3, they've changed it to http.server. This is like a URL where you have a combination of an address, which is the local host, which is your local computer, and the port. So you can run only one of those unless you specify multiple ports. The alternative of doing this is running a server and debugging it with WebStorm directly. And WebStorm is an integrated development environment, which I yesterday sent out links to, which is like something that we recommend that you do, especially if, like, going forward, if you work with multiple files and you want to be able to refactor and you want to be able to dynamically debug your code. Let me just show you like a quick example. This is how WebStorm looks. It probably looks like any other IDE. But then you can also, for example, pick any HTML file and then say debug. And here I'm debugging this DOM animation. And so what is nice now is that I can also set breakpoints. So, for example, here, within the tick forever.
I think you're in the wrong file.
What's that?
Are you in the wrong file?
In the wrong file?
Yeah, because you clicked on DOM animation.html.
Yeah, and I have DOM animation open. I just need to find the right function that loops stuff. Tick forever here. So here now I have set the breakpoint, and now I can inspect the variables of all of these elements dynamically. So this is we can look exactly, pretty much like in the Chrome developer tools. But the nice thing is that I can simply dynamically change something here, hit save, and then it executes again. So this is a really nice way of running. Of developing websites. So here I could resume the program like this. Of course, only resumes it once. Resumes it and immediately holds it again. If I click play, it will continue to loop through that here. And when you have actually some interesting file, let me see. It's not a good example. Well, anyways, if you run real-life JavaScript code and you debug, you can also see the values directly of each data item directly overlaid over your JavaScript code here. And so this is usually WebStorm is a commercial product, but you can, as a student, you can actually get it for free. And so we have provided those licenses. Okay, so it's time to look into, yeah?
Well, I was just going to ask how much back-end development will we do in this class?
None. So we don't we kind of want to keep it simple and not introduce another language and not introduce server concepts and so on. So we'll only be doing front end. You can, for your project, if you, for example, like to do back end, you can actually do it, but we're not going to teach it or require it.
So we won't really be pulling stuff off databases and stuff then?
No, we'll work with files. So it's really more about the visualization design and the front end. We're not going to work with APIs and so on. So this is not a web development class, right? We're these are just a quick starter things that we need to do visualization development.
Just fine.
Okay, so now let's talk a little bit about D3. D3 is this data-driven document library, which was also published as a paper in the InfoVis conference. So you can look at the design goals. It's actually on the recommended reading list. You can look at what it was scientifically designed to do, and you can also look at how it changed, because this is not going to be exactly what you will find in the code. But here, this is the paper that explains all of the major concepts of D3. So, if you're interested in the history of D3, this paper is a great starting point. So D3 is also immensely popular. It's one of the most popular projects on GitHub. So if you go to github.com/D3 and then look at, this is the organization, and then look at the D3 library itself, you can see that it's started more than 50,000 times. And so they just released version 4, and we will be using version 4 in this course, which is, like, this was just released in June. So the majority of the examples that you will find, and including the book, will all be D3 version 3. There's a couple of differences, a couple of caveats. I'll make a note of those when we encounter them today. There's only one or two that we'll look at. But what it actually means is that if you find an example, and there's like many examples out there, that you simply cannot just copy and paste it. It's probably not going to work right away. I'll make a note of where there is differences. There's also going to be, I guess, a seminar talk by Carolina, who is a TA in the class, on Friday on like what are the differences between D3 version 3 and D3 version 4. So if you want to be, like, if you want to come to that, it's going to be Friday at noon. There's pizza served, and it will be in the Evans conference room in the 3rd floor of this building. Okay, so this is the first.
Do you have any visualizations on attendance when there is pizza served versus attendance?
Let me just say that we know that it helps. And so, like, the visualization seminar has 6 or 7 students that are officially taking this class for a grade, and usually it's like about 40 people. But we're not really counting it. Okay, so D3 is a library that has up until recently been like one big library, but the latest version of D3 has split it up into lots of micro libraries, and each of them is an independent GitHub repository. So you can, like, if you know what you do and if you have a build process, then you can simply select only those libraries that you need. We will simply be using like the bulk precompiled version of D3, and we will include it like this. Let me quickly show you a couple of really important resources. The API reference here. Okay, this is the 4.0 API reference here. That is kind of like really a treasure trove of everything D3. If you want to understand how each function works, you can simply go here and look at all of the different functions and properties and explanations in detail. So we can, like, look at all of these different things, and we'll be going through many of them. Like one other great resource for looking at examples that is this blocks. Mike Bostock is the author of D3. He, by the way, used to be a Stanford PhD student, then went to work for the New York Times. So many examples that we'll show in this like theory part of the class will actually be based on D3 and will have been written by himself. And so after, like, he stayed with the New York Times for a while, but now he's like full-time working just on D3. And so if you go to this website, this blogs.org and Bostock, there's other people that have blogs, but here he has many different examples. And so there is like incredibly complicated examples, but there's also some very basic example. I'm just gonna pick some random. So here's every map projection that D3 can do. Then here, this is all static. Let me find something interesting. Voronoi spirals. So you can do something like that with D3. And this like nice thing about blocks is that it has this built-in. Like here is a demo of what is going on, and then it has usually all of the code included. So it's a very common way of simply, okay, what is roughly what I want to do? Look for what somebody else has done, and then take the best parts of it and integrate it with your own ideas.
Does that use SVG?
Yeah. No, it's actually Canvas.
Oh, okay.
But it should be possible to do this with SVG too. It's just not going to be as performant. One of the new things in D3 version 4 is that it can actually render to Canvas too. some aspect of it, like the shapes. I don't know about everything in detail. It can also do these like pan and zoom operations. So there's all these simple examples. And then what is also like, this is an endless list. With many different algorithm implementation and so on. If you go back to like very historical things, then you will find the simple example. So here is a zoomable sunburst, for example. Like when I click here, I get this animation. Then you can also look at the popular ones, which is like sometimes useful. Here we have like a dendrogram, and so on. So like what is very often useful is like here with a tooltip. What is very often useful is to look at those basic charts, see, for example, how was this tooltip here implemented, and then use it. And so here you should always look at what version of D3 is it using, and like as I said, most of these examples will actually use version 3. Like if you see D3 version 3 here, then you have to like prepare for some changes that you have to make. And then of course there's the d3js.org website, where like with the show reel here of all of these different visualizations, and you also have like a high-level description of what D3 can do. So like in addition to the class today, you should probably, and the book, you should probably also go through this high-level description here. Okay. There is also a link to the release notes here of version 4. So this is something that can also be pretty useful. And so there's like not so many major changes in many aspects. What has changed quite a bit is layouts for graphs and for maps and so on. Okay, so let's do an example. This is essentially the minimal D3 example. And what we do here is simply like first we include D3. We have a body with 2 paragraphs. The first paragraph, here is a paragraph and one more. Then we include the script here. And then here we run the selector, d3.select on P. And then we set paragraph.style, color steel blue. And so you're doing exactly the same thing as we did earlier with the standard API, but in a much more concise way. So by simply calling here d3select on P, like this variable will, actually it will only, this is paragraph, because it's only one paragraph that it will select. So d3select returns, in this case, like one single DOM element that is identified. These here are CSS selectors. So here is an example of like a couple of more complicated CSS selectors, or well, maybe like first the style method, like which I also linked here, can be used instead of these pretty tedious set attribute style color steel blue method. Yeah.
So why did it only grab one of the paragraphs to change it to steel blue? Both of them have the P tag.
Because there is another function that is called select all.
So and then just grab the first one, right?
Yes.
So, like,
so yeah. This is actually an example for this. So here, a similar code. There is 4 paragraphs. The first paragraph is here's a paragraph, one more, third one, fourth one, right? And we have this one doesn't have any ID or class definitions. This one has an ID. This one has a class other, and this one has the same class as the third one, the fourth one. And so now I'm showing you the different ways of selecting this. Here I'm selecting by tag, the P. Here I'm selecting by ID with the pound sign at the beginning. And then here I'm selecting by class. And these are exactly the same selectors as we've seen in CSS. And that's like there's like in the standard API you have select element by ID, select element by class, and so on. And in D3 you simply say select and put in the CSS selector. And so, like for each of these variables, like this always contains only one variable because select itself selects only the first element that matches its content. And then you can change that by, for example, calling the style function here. And so I'm setting the P and only the first one to blue. Then I'm setting the second one, the ID, to teal. And then I am selecting the other one, the classes, to dark orchid. And so in this case, this is definitely not what I wanted, right? Because if I select by a class, I usually want to select all of these elements. And so to do this, we can simply use the select all here instead. So I think that answers your question. So like here, we now have not a single paragraph, we have an array of, or a collection of paragraphs. And then when we say, okay, select all of them, we can see that all of them are actually shown in blue. And so if I do other here, the class definition, then you will see that only those that match the other ones, but actually both of them are colored in blue now. So this is all pretty familiar if you know jQuery. Where it gets really interesting, let me see, no, we're not quite there yet. But anyways, we can also, like now if we change just the style, we can also append elements. So here we have a selection, like basically again on the P, and then simply say append a span element, and to this span element append the text. And so one thing that you notice here is that we're doing this for 4 different attributes, or for 4 different paragraphs. What is interesting about this? Why, like, what is missing here? A loop, exactly. There is no loop. I'm doing something for a large collection of things, and there is no for loop or no while loop. And so this is like this declarative approach of D3. So we can take a selection, and we have this data collection of the selection, and everything that I do to this will be applied to every element. And that is what is really neat about D3. Yep.
What if we want to do a loop?
You can hack it badly, but you're not, like, it's not going to be fun. So you don't want to, so you have to get, this is like what takes getting used to D3, this declarative approach that is not very common to write in other languages. But yeah, you can actually, like, if we look at what is the selection, so we can see this is the selection, and it contains, like, you can actually look at the data structure here, and you can see it contains these groups, and in this group it has a node list. And so if you really wanted to badly hack it and really need your loop, then you can go in and work with that, but then you're essentially better off just writing everything with the standard API and not using D3 in the first place.
And then what do you do if you want to like append different values for each?
Well, so you have a data-driven way, like what would be your criterion to decide which element to append to the paragraph, right?
Just a function inside the...
Yeah, so let me get to that. So there's 2 different ways of doing this, right? When I call, this is the next example, so I'll get to it. And of course, I can do this with any, like, again, oh, here I didn't define classes. Anyways, so before, like, now it's going to get a little bit more interactive, and so these next couple of examples are all gonna, there's one weird bug in my code here that you have to change something that this is properly resized. So if you change the code slightly, this will actually be resized properly. So for all of the next examples, there will be this run button here. So that is triggered, that is essentially what then calls back this function here, or this include here, and this calls the execute function. So this run button calls an execute function, and so I am always going to have all the D3 code within this execute function. So just that you know, this is kind of like hidden away here. You don't have to use this, but it is of course nice that when I can trigger an event here, and I can show you, okay, I'm now changing this dynamically. And just for, like, not making everything super long, this is in a separate file. Okay, so here is the first time we actually do something different to each element. And I'm actually also using an SVG here for the first time. So this is initialized, with 3 SVG rectangles that are not very pretty, that are somehow weirdly distributed and of different shapes and sizes. And now I want to do something to them, but I don't want to do exactly the same thing to them, but I actually want to do something different to each one of them. So this is how I do this. I select all of the rectangles simply by calling on the element select, and now the P here has actually all of has the selection of all of the rectangles. Then I set the X attribute to 0. And then I use an anonymous function to set the Y attribute, and this is how I can do data-driven applications. And so these anonymous functions, they have 2 parameters. The first one, usually by convention called D, the second one by convention called I. You can name them however you want, but you should use D and I because everybody knows exactly what you mean by them. D is a data element that is bound to the specific element in the selection, and I is the index of the element in the selection. So if you have the first element, it has index 0. If you have the second element, it has index 1, and so on. And then you can use this to, for example, position your elements. And so here I'm using I multiplied by 90 plus an offset to define its Y position. And then I use the same thing here for the width of this rectangle. I simply take I multiplied by 150 and add 150 so that I have like no null value. And so this is what I get then. I have these 3 rectangles that are of the same width, but we have dynamically, simply by using the I here, we've dynamically spaced them out. And so if I were to add one more rectangle here, the spacing isn't great here, but now I have 4 of those rectangles. So this is how we can, in this case we haven't used data, but at least we have used the position of the elements that we can treat them distinctly. And so this kind of thing here, like setting an attribute based on a function of the data and its position in the selection is the key. And if you only understand this today about D3, then you have made big progress. But this is really critical to understand. Any questions about this?
Can you give an example of using the D?
Next example. Okay, data. Now we'll take a look at data. And so again, there's the API documentation of how to use data. So we have the same initial configuration of SVG, but what we do here is we run. Again, this layout problem. So what we do here is we assign it data-driven values, okay? So how do we do this? We have, and this is exactly the same as before, the upper part here. Then we run a select all as before, so we select these elements, so these are stored in rectangles, but then we assign data to it with this data function. And here we pass in an array. This is the typical data structure, like you want to pass D3 some list or an array in this case. And so we have 3 different data values, 127, 61, and 256. And if we run this, which unfortunately I don't know why, but it doesn't resize, but you can see that this corresponds in pixels to the width of the bars here. So how do we do that? The data here is bound to the DOM. So this is like the rectangle element in the SVG has now a new field, a data field, that is bound to the DOM. So we can then manipulate this. And if we use these anonymous functions with D and I, in this case, we are not using it for the Y position because we just want to space them out evenly and don't do data-driven. Yeah?
Sorry to interrupt. So is the data array associated with each element of rect? Or?
Yeah. So so if there's actually, we can take a look at this. So here I have, so here is the selection, right? And now I can in this array in here, I have the rectangles, and here is the data.
Oh.
And so here we have the individual data elements stored with underscore data. And so this is like a very important skill to go into the inspector here and look whether your data is found correctly. And so these elements are actually saved in the DOM itself. It's not, like D3 doesn't do any like specific data managing, it just does transformations and assigning stuff to data.
So what would happen if the size of your array is not the same size of your array?
Wait a minute.
Okay.
Oh, this will be the next, the next couple of examples. Okay, so again, here we assign, like here we're not using the data, but here we are for the first time using the data. So here we define the width as a function of the data and of only the data. We could also do something like data multiplied by 2, and then we would get bigger bars. Now the bars are bigger. Let me reload this.
If you don't call that data function and pass in the array, is D undefined?
Yes, or empty. Like it's not defined. Yeah, it doesn't have some value. Okay, now it resized. Okay, so here now if we change anything here, divide by 2, for example, then we'll see that this is smaller. So we can take data, but we can also transform the data, like essentially apply some kind of transfer function to it. This, in this case, is divided by 2. Okay, this was the first time we have done data-driven styling of a chart, so this is like a milestone now. So let's look at the problem that we just discussed. Here we have an array with 4 elements, but we only have 3 SVG elements. So we have, like the selection here will only contain 3 elements. So what do you think will happen?
Omit the last data.
Yes.
Only use the first 3.
We only see the first 3 appear. So by default, on the selection, if there's a mismatch between the size of your array and the selection, and if you don't take special care of that, it will simply apply only to this to the elements in the selection where there's a match from the data to the selection items. So here we simply do this exactly the same, but we have one additional element. So what can we do about this? We can actually, there is a special selection in D3 which is called the enter selection. So the enter selection is like, so here I have the standard selection, I'm assigning it to the data, I have the same like SVG again at the beginning, and with this enter selection, like here the standard selection, and I'm assigning it like to exactly the same way in blue with value D, and here I take the enter selection, which is dynamically generated for all the elements that don't match to the original selection, and then I call append rectangle. And so here I am taking for all of the elements that didn't find a match, I'm appending a rectangle. And so here I'm just putting it at position 1010 with width and height 30 and fill it green. So when we run this, we can see, okay, now we have 3 data-driven bars and 1 new rectangle in green. So what will happen if I click run again?
Another one.
It will add another one? So now if I click run again, in this case my SVG already contains 4 elements, and I have 4 data elements. So if I click run again, what should happen?
You have to get 4 blue bars.
It will update the value.
Another one.
Yeah, it will actually add the blue bar as we would hope it does. So because we had created this element. Okay, and now this wasn't really great because we we had just created an element and it didn't look the same, it wasn't positioned correctly, it wasn't assigned correctly, and so what we can do is we can simply copy this over. So we can simply take the original selection here and then use the enter selection here and do the same thing to it. And here everything is the same with the exception of the color here being green. And so what happens if I do this is I get a nice layout and I get the right width, but this is rendered in green. By the way, this is something that is new in D3.4, that the enter selection doesn't contain, the enter selection used to contain a merged selection. Now it's only the enter element, so it's two disjunct sets of selections. Any questions about this? Yeah?
So I was curious, so I just tried putting the enter selection above the,
Yeah?
changing the attributes. Why doesn't that work? Like, why doesn't that, so like...
Wait, in the previous example? In this
Yeah,
example?
so like if you add the rectangle first and then change the attributes, but it didn't work like that.
So like this?
Yeah.
The reason is that the selection here, what you get by enter is actually not the original selection here, but you get, like this, the original selection only contains the elements that were already there, but has like a special, like in this function you can get all of the unmatched data items. So the selection here refers to a different collection. If you call enter here, you actually get another selection object. But in this case, a disjunct selection object. So there's the original selection, so the order here doesn't matter. It's just about what am I referring to. Yeah?
What happens if your data size is less than your element? That's the next example.
Exactly. Okay, where was I? Well, then one but next example. Okay, so here we have the green one, but of course duplicating code isn't really pretty. So what we can do instead is we can merge these two selections. So here we have exactly the same example again, same initial SVG, 4 data points. We map the data here. This is the selection that by default now contains only those that had a match between the data and the DOM elements. But here, by calling enter, append, and then merge to the original selection, we get a new selection that contains all of these elements. So what we've done here is we have an enter selection and a selection that actually matched the original selection, and we have a enter selection with 2 elements, and then what we created is like one joint merge selection with the 5 elements. However, those 2 still exist. This is a new copy, so this is something to be aware of. And this explicit merge, and if we apply this explicit merge, we can now, like here, we assign it to this variable, so we are overriding a variable. And now we can actually just use one way of styling it, and all of them will look the same way. And so if we add more data here, this will of course work. So this is now we can essentially take an arbitrary number of elements in our original SVG or in our original DOM and apply any data set to it, and it will have at least the right size. So what happens if you don't have any elements? Well, usually you actually don't want to like draw up something in SVG first, but you rather want to generate all of the elements from scratch in a data-driven way, right? That is much more interesting. And so what you can do is you can actually run these selections even on a completely empty set. So what I'm doing here is I'm svg.select all rectangles, and here I'm selecting on non-existing elements. And that is a little bit weird, because you're selecting elements that are not even there. And so this is going to be empty, but then like I'm mapping it to data, and once I have mapped it to data, I actually have so this here would still be empty if I were to remove this enter here and the append, then nothing would appear. But if I add this enter, I can actually I can operate on this enter selection, append the rectangles to each of these placeholder items in the enter selection, and then dynamically style it. And so here I'm creating, like I simply have an empty SVG, and I'm creating all my rectangles from scratch. So I'm actually building a visualization without any pre-initialized SVG. So this is also important. You can select on whatever. It doesn't here in this case. Actually, what I can do is I can select whatever input. So what happens now if I click here?
Same thing.
Yeah. And so one of the co-authors of D3, I saw him give a talk before, and he said, you can do this, but if you do this, I will find you and shoot you. So it is just really bad practice. It is like, if you select on something, even if it isn't there, like, I don't have to put anything in here, but you should always select what you really want to select, because otherwise it's just going to get terribly inconsistent and extremely error prone. Yeah?
So each function that we have here, for example, data, attribute, we are basically consecutively calling these functions on the previous one.
Yes, so this is actually a good point. It's in the notes, I forgot to mention it. What we do here, which is also like very D3 specific or well, functional language specific, is this chaining of methods. Whenever I call like an attribute, it returns again the same item. And this is how we don't have to store these variables somehow and then call always on variables. We can simply use this chaining syntax. It's a really good question, yeah. There's a note, but I forgot to mention it. Any other questions? Okay. So next, let's take a look what happens for deleting elements. Right, so here I have my example from before, the 3 ugly charts. And if I run this, then I simply apply the styling to 2, but nothing happens to the third one that is left over. So here we have a data set with only 2 items, and we do the standard mapping of the data items. This one is left over. So this is something that we don't want to do, so we also want to be able to do graceful exits. And so to do graceful exits, similar to the enter selection, we have a separate exit selection. And so if we actually look at these selections here, you can see these explicit here. Here's the enter selection, and then here's the exit selection, and this groups is the default selection. So you can always look at those and see exactly what they are in the inspector. So, and then in the exit selection, we can actually call remove. And so here we style everything just as before with the selection that matched data to DOM elements. And here we take all of the elements that were in the DOM but didn't find a match to the data and remove them. And so now what we get is 2 bars. Any questions about this? Okay, another really cool feature of D3 is transitions. How would you do a transition? For example, if I had these 3 bars, and if I want to map them to a different position and a different size and so on, and so what you can do is you can simply find if these elements, they stay consistent, right? The DOM element has the same identifier, it's still saved in the DOM. What changes are its attributes. So you can do an interpolation function between the attributes that includes the color, that includes the position and the size and other attributes. So you can actually do things like, let me show. You can do things like this. And this is all just interpolation. Same data sets, different mappings, and interpolated between them. So we keep it a little more simple for now. So what we do here is we simply say on the data we have a transition of duration 3000 in milliseconds, and that's all it takes. And now the style is applied in a smoothly animated way. And if you were to implement this pre-D3, it would take you quite a while. And in D3, it's just those 2 lines. And it simply takes the DOM elements at the previous position, matches them to the new position, transitions them within this duration that you can set. And I can make this lower, of course. I can say 6 seconds. No, it's just going to be a little slower. And you also notice the color change. So, gradual color change. See how the linear interpolation is also like this is gradually getting more blue. So it does it for all of the variables that are where it's possible. So again, we had 4 data items. But out of the 4 data items, again, we haven't handled the answer selection properly. So let's take a look how we can handle this answer selection properly with transitions. So here, we take the original, we run a selection of rectangles, apply the data, we take the enter selection, append the rectangle. The rectangle is initially applied at position 200, 200 with 10 by 10 in red. Then we merge it to the selection. Now we have all of the DOM elements in here, and then we style it. But we don't style it immediately, but we again use a transition of 3 seconds. We position it, we set the width and height, and we set it to blue. And then we start another transition. So I can always chain this. I can say, start another transition, take another 3 seconds to do this, but in this case, delay it for 3 seconds before you do that, and then fill it with green and make it like 50% wider. And then finally, we also take care of the exit selection. So we want to be able to fade out items dynamically. And so what we do is we set opacity is 1 originally. Then we start the transition for 3 seconds, and then we interpolate that to opacity 0. And then when that is done, we dynamically remove the item. So this is how that looks like. We first start with the red rectangle, and then it gets entered and transitioned in here. So I shouldn't have. But let's look at this again. The red rectangle appears, it moves over, and then after 3 seconds, it transitions again. In this case, makes it bigger and green. And so this is how the show reel, for example, is implemented. We have these different change transition states. And now let me see if I were to remove some elements here. We can also see this graceful exit of the element by, or not really. So in this case now, we had already merged the selection, that's why it didn't work. But now you saw this graceful exit of the element by simply fading out, by interpolating towards like opacity 0, and once it was actually removed, once it was invisible, then it was actually removed from the DOM with the call to remove. Okay. So today we've only talked about bars. There is, of course, also other objects, but I think the bars are great to illustrate the whole thing. For your homework that is due next Friday, like what the goal of this lecture is also to give you all the tools that you need for the homework, so we'll briefly talk about lines. And so this is how you have done lines in homework 1 by using this path, SVG path element, and then position them manually. And so we can, well, in this case we're just appending a path without taking any data into account, but we can also do this with data-driven, like in a data-driven way, of course. So here we're defining like a number of points, an x position and the y position of each of these points. And so the X position here is just continuously increasing, and the Y position fluctuates. And then we can call this D3 line function. And so for, this is again like, this is now bound to D. So for X we set simply the value of D dot X, and then here we set the value of D dot Y. This is like simply, here we have an array of objects, right? Or dictionaries, however you want to call it. And here X and Y is like, this is bound to one of these objects. So if we, for example, were to log this, well, we can also always log a D in here to just see what happens with the D's. And so now we have created this line here in a data-driven way, but we can also look at what was in this selection. And so here the groups should have like the data here. Okay, that's not the right selection. Didn't print. Oh, if you print something after return. Yeah, so here we're printing essentially just the data's elements, and the data's here are object with X and Y. And so this is like a good way of debugging what you're actually doing with the D's in any of those function calls. And so here we're setting the X and the Y in this, for this line function, and then simply say here line function and put in the points. So this is essentially this generator, like this generator function here, and this is completely independent of SVG or whatever. This simply generates the SVG code that you would need for the line that matches to these data items. And so then, like here, I can run this, and I can see that this is updated. And if I were to change the data here in some way, say, like this is also 200. Then run this, you can see that it has updated accordingly. So another thing that is nice is that this is like, this line function is pretty powerful. So like I'm showing you just the default here, but there is like a long list of different curve interpolations that you can do. So if you go to this link, you can take a look at all of the different fancy curves that you can do based on that. And so here's a couple of examples. So a Catmull curve. You can see that now we have a curve, or I can say, let me reload this to the original data set. I get this Catmull curve, and this is a parameter, like an alpha parameter, which I can modify in some way, and then get it updated like this. There's other curve functions here. For example, this curve bundle, where we have this beta factor. And so this is like a smoother curve. We can increase the beta here to 0.9. We'll see that we have a more ragged curve. So this is how we can do these line interpolations. And again, this is something that is pretty complicated to implement, but it's pretty convenient and well done and nice in D3. And so combined with this idea of binding data elements to the DOM directly, all of these library functions that D3 makes available, this is a pretty powerful visualization technique. So this is the basics of D3. Next time on Tuesday we will be talking about how can we make charts with axes and so on, how can we do transitions, how can we look at this in more detail. But this should be everything that you need for your homework too. Thank you.